In former and current military operations, soldiers run into many problems with landmines and other traps that are placed underground. Previously, mine detectors have all been handheld, which posed a threat to the operator. But by developing a quadcopter attached metal detector, this would reduce the threat of landmines to the operator. To do this, first the goals and objectives of the project were determined and the outline of the project was set. Next, a design and schematic was developed, followed by the bill of materials and assembled and put together. Once tested, it was determined that there was problems with the board, but there's still work to be done.
The main goal of this project is based on a design that consists of a metal detector that must be mounted to an XI-320 quadcopter. Some requirements are that the drone must be able to fly freely, and that means it has to weigh less than 1.5 kilograms, including the PCB, battery, chassis, and coils. It also has to detect the presence and type of metal using a BLF architecture, which is a very low frequency architecture. The final budget for this project is approximately $145, and this is just an estimation because the cost for the 3D printing of the chassis is still unknown.
Now we'll move on to the design overview and schematic section of our project. Here we have the signal flow diagram. This shows how the electrical circuits included in our design pass along electrical signals and use them to function as a metal detector. It begins at the generation of the transmit wave by the oscillator, covers the reflection of the wave, and shows how the system interprets the received information to detect the presence of metal. Included below the signal flow diagram are the schematics of the individual modules in the design, to give a bit more detail as to how the specific shared connections between modules of the system come together to accomplish the task of being a metal detector.
Drone integration. The chassis was designed in SolidWorks, and it has to be able to hold the coils and the PCB and attach to the quadcopter. It has been designed to weigh as little as possible by including only the necessary support for the coils and the PCB, and it will attach to the quadcopter using a Velcro strap.
I'm going to go over the results and the challenges of our project. So the receive coil is able to detect large pieces of metal, but with smaller pieces of metal it's not able to detect them as well. So we are working with the inductive balancing of the coil in order to improve the sensitivity. We've also gotten rid of the phase detector and replaced it with a algorithm that we will implement on the MCU itself. And then with the JTAG connection with the MSP FET to the MCU, we have had challenges making a connection, but we were able to fix it by resoldering the MCU.
Conclusions and future work. The purpose of the quadcopter metal detector is to reduce the threat of landmines that have yet to be extracted from former conflict zones. Designing and building the metal detector was challenging since it includes many components and features, such as inductively balancing the coils, building a chassis to attach to the quadcopter, and programming the MSP. The chassis has been designed but is not yet printed and attached to the quadcopter. The code must be downloaded to the MCU, tested, and optimized to be able to interpret the received coil signal. The full drone integration needs to be done by attaching the circuit components to the chassis and ensuring that the drone can fly freely.